Okay, so uh, let's start our class. So we have started to discuss components of uh, components of a satellite communication system. As we have discussed last week, uh, the components we used for satellite communication system depends on uh, depends on the type of orbit, and it depends on the type of service provided by the satellite. So when you say component, it's not the same for all services. It's not the same for all orbits, but generally we have said these components categorized into two subsystems. So the first subsystem is what we call it a space segment subsystem. Okay. So as you can see here, satellite subsystem divided into two: space segment subsystem and ground segments. So we have started the space segment subsystem. Again, space segment equipments which are in the space are again divided into two: bus and payload. Okay. So when we say components categorized under bus, we mean equipments, devices which are used or employed to give supportive services, not services like communication and so on. They are designed and put in place to provide supportive like physical structure, controls purpose, controls the altitude, controls the temperature, power system, and all these supporting structures. We classified them as bus. Another part of the space segment, what we call it payload, uh, equipments, devices which are intended to give services. In this particular case, we are discussing satellite for communication service, right? So equipments which are designed or constructed or put in place in space to provide this communication service, we categorize as payloads. So what are the two common payloads in space? The transponder system and the antenna subsystem. So we started the transponder subsystem of the space segment last week. So when we say a transponder, we mean we does not mean one component. When we say transponder, it is series of components interconnected together to provide this communication service, what we call it a transponder. So so when you see this transponder, this is typical communication transponder. So I'm sharing here with you a video which shows the transponder. So as you can see here, the satellite transponder is series of components we put in space in orbit for providing communication service. We call it a transponder. So as you can see on in this video, so the equipment in space, what we call it space segment, consists of structure called bus, consists of subsystem called payload. So transponder is one of the payloads we use in space. So so look here. So here, this part is our transponder, one transponder. Where do you find this transponder? In the space segment. So this is the antenna, which is not part of the transponder. This is the transponder. So as you can see inside, there are different devices. What is the first device we have discussed? Low noise amplifier. Okay. Then the local oscillator and mixer, which is used to frequency translation. We have different components interconnect together. This one block, what we call it, a transponder. So the first device, low noise mixer, then this is the amplifier ring, then it will be transmitted back to the earth. So this important device, what we find inside the space segment, it's called a transponder. So we have seen last time a device called low noise amplifier, and we have seen what we call it a frequency translator. So this device we have discussed last class, the noise amplifier and frequency translator. Today we'll see another part of a transponder, which is the high power amplifier. But before that, I want to discuss with you how many transponder in one satellite. It's not only one transponder. So let's see the antenna. The antenna. This is our antenna, which receives signal from the ground, uplink signal. Okay. So this antenna, this satellite has bandwidths 500 megahertz bandwidth satellite, 500 megahertz bandwidth satellite. Okay, so the frequency range can be from 40 gigahertz up to 14.5 gigahertz. What is the difference between these two? 500 megahertz. So this is the total bandwidth of this satellite. Okay, so What the next device we have is what we call it low noise amplifier, LNA, which I showed you last time. This low noise amplifier is designed to amplify bandwidth 500 megahertz. Okay, 500 megahertz amplifier. So the whole signal is amplified. Why we call it low noise amplifier? Because it has high gain, high bandwidth. You can see the whole 500 megahertz signal amplified by this low noise amplifier with a gain of, let's say, 60 dB, million times. But this, why we call it low noise? Because it adds minimum amount of noise. Noise mostly generated from inside or it comes from outside. So we need to minimize noise generated by our own system. So this amplifier is called low noise amplifier because it generates very small amount of noise. That's why we call it low noise amplifier, as we have discussed here. These are different type of low noise amplifiers for GVS purpose, for broadcast, TV broadcast purpose, and so on. So next, this signal, which is 500 megahertz, divided into different carriers. So the first carrier goes to the first transponder. So this is transponder number 1. This transponder number 1 has only 36 megahertz. Now, what is inside the transponder? When you say transponder, it's series of components. So the first device you will find is a mixer. Okay, mixer, which convert incoming high frequency uplink to downlink frequency. The next device we may have is high power amplifier. Okay, high power amplifier. TWT, traveling wave tube. I will explain TWT later. This high power amplifier, it only amplifies the 36 megahertz carrier. Okay, 36 megahertz carrier. There is another transponder, transponder number 2. Okay, this transponder number 2, and it continues. So in one satellite, there are 12 transponders. Transponder number 12. Each one, how much bandwidth? 36 megahertz. 36 megahertz. Okay. So total bandwidth, the 500 megahertz divided into 12 carriers. Each carrier processed by one transponder. Transponder is nothing but a processing device. It changes frequency, it amplifies the wave signal and retransmits back to Earth. So in these satellites, how many transponders are there? 12 transponders. So it depends on the application. There are a number of transponders in one satellite. Okay, so we have discussed the low noise amplifier in the transponder block diagram. The first device we have discussed is low noise amplifier. Then we have discussed the frequency translator, as you can see here. What's the next one? Another very important device is the high power amplifier. Because when it transmits signal from ground, it travels thousands of kilometers. The signal will be weak. This very weak signal must be amplified by using high power amplifier and retransmit back to Earth. So what is this high power amplifier used in most satellites is called traveling wave tube amplifier, TWT amplifier, traveling wave tube. As you can see here, this different type of traveling wave tube amplifiers. High power amplifier, it is tube amplifier. So we have discussed this in radar also, because they are common in radar. Okay, so look here, we have how this TWT, because it is small size, the size is very small. This amplifier's size very small device, and it has high gain. Compare with klystron amplifier, compare with crossfield amplifier, different type of high power amplifiers. For satellite communication, TWT, traveling wave tube amplifier, is very common. It's very important device. So we are going to discuss today this TWT amplifier, which is one of the important components of a satellite transponder. When we say satellite transponder, we mean what? It is a series of components. Why we need a transponder in space? Because we need to process this information, right? Before we retransmit to another part of the globe, signal must be amplified, the frequency must be translated. All this processing is performed by the transducer. So what's one of the major components of a transponder? High power amplifier, specifically traveling wave tube amplifier, TWT. It's very important device, not only in satellite, in radar, other high power telecom applications, microwave relay systems. It's very common to use TWT, traveling wave tube amplifier. So let's discuss TWT. Okay, so we are going to discuss traveling wave tube. This is microwave amplifier, what we call it, traveling wave tube amplifier. So, which is very common, high power amplifier. It is not semiconductor amplifier. This is called linear tube amplifier. So as you can see here, there is inside this, these are supporting equipments and so, but this part is the traveling wave tube, TWT amplifier. So let's open. This is the TWT. This is the TWT amplifier, high power amplifier. So let's see what is inside. I'll explain for you. It's opening the amplifier. So this is the input port. Okay, this is rigid coaxial. This is, as you can see here, we give the input signal, very weak RF signal. This is the rigid coaxial cable for the traveling wave tube. So it has two ports. One you see here for input. This one is for we take output. Here we give very weak input signal, RF signal. It's amplified inside this tube, very high amplifier, and you will get the output in the second port here, which is the output port. So you see two ports. Now let's see what is inside. So when you see inside, you will see this coil, right? So okay, so this is the electron gun. What here you are seeing the what is the internal structure of a TWT, because very important device. That's why I want to discuss with you. So this electron gun, and this is the so as you can see in the TWT, this structure, what we call it, electron gun, which generate electrons. We apply DC voltage on this electron gun. Here we apply DC voltage, negative, sorry, this is positive part, negative, and to the collector. Okay, so what type of voltage we apply? DC from our battery, DC energy. So here you see the weak RF input port I showed you in the video. So signal, the RF power is come here, passes through this helix structure, and you will get it the amplified output here, as we have seen in the video. Now, where this, if you apply here 1 microwatt RF power, it may be amplified to 10 kilowatts. You can see how much the power is amplified, right? More than a million times the signal is amplified by this TWT. So amplification means we have additional energy. Where this additional energy comes from? As you know, from conservation of energy, we cannot create or we cannot destroy energy or power. What we can do is convert one form of energy into another form. Now, in this case, we need to convert the DC energy from our battery. Here we apply what? The DC voltage. Negative terminal to the electron gun, positive terminal to the collector. Here we have a collector, it's positive terminal. Here we have the negative part, which means electrons. So electrons, negative charge. This collector is what? Positive charge. So as you know, negative charge is attracted by positive charge. So these electrons starts to move, focused, and starts to flow through this helix structure. The helix structure, as you can see here. Okay, so this is RF out. Here we have RF in. Okay, here is the electron gun. Okay, electron gun, which generates these electrons. So when electrons passes through the helix structure, energy transfer takes place from the electrons, which is DC energy, into what? Into RF. Energy exchange takes place between the, you know, when electrons accelerate through this, there is a high kinetic energy. This high kinetic energy in the form of velocity modulation transferred to RF. So the RF power energy now boosts, increased. it takes energy from the electron and the RF power is amplified. That's the basic principle of TWT amplifier. So as you can see, different type of traveling wave tube. This one is TWT, traveling wave tube amplifier, for C-band, X-band, and Q-band, which is used for direct broadcast satellites. Okay, this is another type of TWT amplifier, which is also used in these bands, and this is another TWT amplifier. They are very different types. Very important device in today's telecommunication systems. Okay, so we have discussed so far a transponder. What's a transponder? Device, communication device we put in space. Why we put it? To process the signal. When you send a signal from ground to space, as you can see here, when you send a signal, what will happen? During transmission, if you transmit your information, let's say X of t, a signal X of t for analog transmission, okay, or digital transmission, it can be our video, audio, combination of this information. If it is digital, you modulate it on analog carrier, transmit it to the space transponder, the satellite here. So it's very far distance. So what will happen? The signal will be attenuated. X becomes X prime. What does it mean? It means the amplitude decreases. As you know, when a signal transmits longer distance, the amplitude is going down because of attenuation, free space loss. So they are not the same. This is X. This is what? X prime. Another one. Signal is delayed by some. Here is X of t. What a signal reach here is delayed by some factor, tau, which causes phase shifts. Okay. In addition to this, there is another signal, noise, right? Different type of noise. So when you send a signal here, what reaches on the satellite is very distorted, very weak signal, distorted by noise. Attenuation is very much high. There is phase shift due to the time delay. All this distort the signal. That's why we need what? We need a transponder there. This transponder will receive this low distorted signal, amplify it again, change the frequency from uplink. Here we have uplink frequency. This uplink frequency converted into downlink frequency, right? For different reasons. So this transponder is a very important device. It changes the frequency, it processes the signal, it removes noise, it amplifies the signal. So what is one of the main components of a transponder? This high power amplifier. We call it HPA. Which high power amplifier is very common for satellite communication? We call it what? TWT, traveling wave tube amplifier. Why we choose TWT? Because it is a small size. You have seen on the video, it's very small size. If you see klystron amplifiers are very big. Okay, so it's not possible to put very big amplifier in space. We need a small device like TWT in space. What's another application or advantage of TWT? High bandwidth. High bandwidth. Okay. As we have discussed, these satellites bandwidth is how much? 500 megahertz. 500 megahertz bandwidth. It carries so many TV channels or data rate, high-speed data rate, right? 500 megahertz. There is no amplifier. to amplify this 500 megahertz. So that's why this 500 megahertz divided into how many parts? 12 parts. Each one transponder. Each one is how many? 36 megahertz bandwidths. We divide this 500 megahertz into 36 carriers. Up to what? So this is carrier number 1, carrier number 2, up to 12. Each carrier, how much? 36 megahertz. So total will be 36 times 12, total 500 megahertz. Okay. So why we need to divide it? Because this amplifier can amplify up to 36 megahertz, maximum 40. One amplifier. Okay. So for each transponder, we put 1 TWT. Each transponder has 1 TWT. So 1 TWT, traveling wave tube amplifier, amplifies the first carrier. Another TWT amplifies the second carrier, and so on. If you use klystron amplifier has a bandwidth of only 8 megahertz. Okay, so is it possible to use klystron to amplify 36 megahertz channel? No. But TWT has high bandwidths compared with a klystron. That's why one of the advantage of traveling wave tube amplifier is its high bandwidth. It's enough to amplify one carrier, 36 megahertz. So how many TWTs are needed in the satellite? 12. One carrier, 36 megahertz, amplified by 1 TWT. Another carrier amplified. So after amplification, all these 36 channels combine together and retransmitted back to the Earth. Okay, so how it works? We receive the uplink frequency from ground. Then what will happen? We have one low noise amplifier. Then this 500 megahertz bandwidth divided into 12 carriers. Okay, up to what? Up to 12. So this is 12. Start from 1. Each one is transponder. This is one transponder up to 12 transponders. Each transponder has what? Its own TWT. Each 36 megahertz. This is 500 megahertz. This is 36. This is 36. Total how many? 12. 12 times 36, 500. So each one is amplified separately. Then we combine them together. And after combination, we transmit it back into the Earth. That's downlink. This is what? This is uplink. Okay, this is uplink. So this is how we works. So as you can see here, these TWT amplifiers are very small in size. So we use it in the transponder. So what are the 3 main components we have discussed in the transponder? Low noise amplifier, frequency translator, and the high power amplifier, which is TWT. Now,